Hello U9, we've got another video help revision. This one's on scientific notation. Now let's just remember a couple of key issues before we get into it. The first one is that what scientific notation is for, and the purpose of it is to reduce the size, what's called abbreviate. Very large or very small numbers. Basically numbers with lots of zeros. So that's the purpose of scientific notation, is to make an abbreviation of those sort of numbers, and you can see there's 4 examples here. So that's scientific notation is an abbreviation, and the form of it is a number, I'll call it number n, times 10 to a power. And the number here, this one has got to be between 2 and 10. Between those two. Okay, so let's have a look at the process. Now we've got 4 examples in front of us. So the process firstly is to take the significant figures in the number already. So let's go significant figures in the number, and this first one has 3. So part A, I'm going to take those 3 significant figures, 764. Now we've got to turn that, modify this so that that number, those 3 numbers become a number between 2 and 10. So we've got to find somewhere to put the decimal point. A decimal point in here will make it between 2 and 10. And the only place really we can put it is between the 7 and the 6. So we get 7.64. So now we've still got the significant figures the same, but now we've made this first bit in line with the format. Then we're going to multiply by 10 to the something, a power. So at the moment 7.64 is a lot different to 764 billion. So now we've got to find a power that changes this back into this, and that's the power that moves the decimal point back to the right. And in this case, so we just count the number of places that it has to move. So at the moment it's here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's got to go 11 numbers to the right to get it to back the decimal point from where it is here back to here. Times 10 to the number of places we had to move, 11. And that number there is the same as that number there, just abbreviated. 7.64, number between 2 and 10, times 10 to the 11. That's the same as that. So now we've got our abbreviation in scientific notation. Next one, I'll try and go a bit faster for this one. 6,000. So 1 significant figure times 10 to a power. There's no decimal point anywhere, but it's actually here. So to get it back to 6,000, we have to move it to the right 1, 2, 3. 3 places. 6 times 10 to the 3 is the same as 6,000. C and D decimals. Let's move this around. Here we go. I need that there still. Okay. Let's do them over here. C. 0.0008. One significant figure. So we use that. Decimal point now is here. So I have to move it back to there. So we're going left this time. There we go. 1, 2, 3, 4. 4 places. Now because we go in the opposite direction, I'm going to put that on a calculator just to show you that that and that are the same. Except this one is the abbreviation of that one. Where's our... There it is. Okay. There it is, 8 times 10 to the power of -4. That should end up with 0.0008. There you go. So they're one and the same. But this one here has got to be in the right format, so we've got to have a number between 2 and 10 times 10 to a power. That's what makes scientific notation. Okay. Last one. D. Lots of zeros in this one. Only 3 significant figures though. 472. We're going to put the decimal point in, so it's a number between 2 and 10, sorry. There it goes. 4.72. There it is over here, 4.72. To move it back to the left, we go 1, 2, 3, 4, 5, 6, 7 places back to the left. 4.72 times 10 to the -7. So over here. To the -7. There's our scientific notation, and there it is. That's, oh, I can get it close. That's the same as that one. So remember, scientific notation is an abbreviation. It reduces the size of numbers with lots of zeros, and we have to have it in this format. And so the way we do it is use significant figures, create a number between 2 and 10 with those significant figures. Then we have to move the decimal point back to make it the numbers the same. 7.64, we had to move the decimal point to the right 11 places. 6 times 10 to the 3 had to move the decimal point back 3. This one's from 8 back to 0.0008. It has to go to the left 4. And this one had to go to the left 7. So when you're moving the decimal point and there's no decimal point, we have to move it right to the end. Right to the end. When you've got a number, a decimal number, you have to move it back to the left. So it's 0 point whatever it is. Okay. Let's do a few of these. 1A. Scientific notation. Take the two, there's 2 significant figures in this one, 2 and a 4. Put the decimal point in between them because that'll make a number between 2 and 10. But then we've got to move the decimal point back so it equals this. And that would be 2.4123. We had to move the decimal point back 3 places, to the right 3 places. Let's go C. Lots of zeros in C, there's 6 of them. So we take the 2 significant figures, the 2 5s, put a decimal point there because now that's a number between 2 and 10. Then we're going to move the decimal point back from now where we put it, back to there. And we go 1, 2, 3, 4, 5, 6, 7 places. So now this is the same as that, but in the right format of scientific notation. Let's move forward a bit to, let's do F. 3, 4, 8 are the significant figures. This time there's 3 significant figures. So now we use these 3 to make a number between 2 and 10. So the decimal point has to go between the first 2. That's in the right format for this one, number between 2 and 10. And now we've got to move the decimal point back to here. Going 1, 2, 3, 4, 5, 6, 7, 8 places. Okay, a couple of decimals. Let's do Q and W. That should do us. Okay, Q. Only got one significant figure. And now the decimal points here, we've got to go back to the left. 1, 2, 3, 4, 5, 6. Going left, because when you're starting with a decimal like this, the scientific notation is a negative number. Decimal. So when you've got decimals, the scientific notation includes them negative in the power. When there's no decimal, the scientific notation is a positive number. W. 2 significant figures, 7 and 8. Put the decimal point here to make it a number between 2 and 10. And now we're going to move the decimal point from where it is here between the 7 and the 8 back to where it should be. 1, 2, 3, 4, 5, 6, 7, 8 to the minus 8. Okay. All right, let's do just a couple of these. Part E, the nearest star to Earth, excluding the Sun, is Alpha Centauri, which is a long way away. 4 with 3, 6, 9, 3, 6, 9, 12, 13 zeros. So take the significant figure as only one of them. And there's a decimal point back in here, just at the 4. How to move it back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. So that is the same as that. Okay, part F. Thickness of a piece of paper is 0.00012 meters. Turn that into to scientific notation. Take the 2 significant figures that are there. That's a number not between 2 and 10, so we have to put a decimal place in here. Number between 2 and 10. Then we have to put the decimal point back. There it is now, 1.2. In between there, we've got to move it back to there. 1, 2, 3, 4. Okay. I think we get the idea. I think that's it for that one. Significant, the scientific notation. There's also questions on it using a calculator. Let's just see if I can get there. Trying to remember, times 10 power of 5. I think that's how you do it. Yep. 1.2 x 10x times 10x to the power of, say, 4 times 3.6 scientific notation, 3.6 to the power of 2. The calculator can do those sort of questions as well. There you go. Okay, I think that'll do us. Thanks everyone.